Welcome back. In this video, we'll continue talking about simulation with a focus on the normal distribution. Chapter 24 is what we're continuing. There's no mini exercise associated with this video, but it's important background on how we simulate data in Excel, because we'll simulate normally distributed data quite a bit. Let me show you what I mean. So we started last video, among other things, simulating data with the RAND function. That simulates some number between 0 and 1. And we'll use that to feed into simulating a normally distributed random variable. And a little bit of background is in order on how we go from like some RAND function to a uniform distribution to a normal distribution. So some more detail, right? The RAND function, if we look, is a uniform, follows a uniform distribution. And in Excel, just to illustrate, if we do the RAND function, right, what I mean is a small number like 0.21 is as equally as likely as a larger number like 0.69 or 0.9069. So if I were to draw the probability density function for the RAND function, right, a uniform random variable, a lot of stats in this part of the course. Helpful to review some of your Stats 202 notes or there's plenty of background videos on probability and statistics. Feel free to check those out. But here's the probability density function for the RAND function. Right? It can take a value between 0 and 1, and then the height of this line is how likely different parts of this distribution are to occur when we simulate it, right? And so the height is the same, meaning that the small numbers are equally as likely as the large numbers. And actually what I'll write down is for the RAND function, we'll treat that as a simulated percentile. So keep that in mind as we look at the normal distribution, which looks a lot different, but you've seen it before. Where if I were to draw a normal distribution, right, draw the probability density function of that, different parts of the curve have different heights, right? So it's centered at the mean, mu, and then we've got some standard deviation, sigma, that tells us how spread out the curve is. And we know that with the normal distribution, observations closer to the mean are more likely because the curve is higher there, right? And then we also know that, like, okay, so suppose I do look at the tail of the distribution. Suppose this corresponds to 1.64 standard deviations below the mean, right? So that corresponds to a z-score of negative 1.64. Right? We know the area under that part of the curve to the left of z equals negative 1.64 is about 0.05. Okay, and then remember, to make a z-score, right, if I have some observation x, a z-score is just subtract the mean and divide by the standard deviation. Z equals x minus mu over sigma. So we know that this p equals 0.05 corresponds to a percentile, right? So the 5th percentile of the normal distribution corresponds to a z-score of negative 1.64. In other words, 95% of the time, if I keep drawing random observations from a normally distributed variable, I'll get values that are like greater than or equal to negative 1.64 distribution standard deviations below the mean. Okay, well, let's map that to a simulated percentile, right? So z equals negative 1.64, and then a normal distribution that corresponds to p equals 0.05. The area under the curve to the left of z equals negative 1.64 is 0.05. Right? So in a normal distribution, the 5th percentile of outcomes is at z equals 1.64, or 1.64 standard deviations below the mean. Okay, so this might seem a little abstract. Let's try simulating normally distributed variable. If you go over to the simulated market returns tab of this April 16th simulation spreadsheet, got a lot of different data here, but let's go over to the right side of the spreadsheet. And what's going to feed our simulation is historical S&P 500 returns going back to 1950. I've got monthly returns going back to 1951. And then based on the historical data, we've got a historical average return of 0.69% per month. The sample standard deviation of the historical data is 4.12%. So let's make a simulated return. And then I'll start by putting the random number, the RAND figure, outside of the simulation function like we did in the previous video. All right, so here's some random number between 0 and 1. And then we'll make a simulated return based on that, based on the random number. Let me show you how the syntax of the function, right? So the norm.in function, norm.in is how we're going to simulate normally distributed data in Excel. It's got 3 arguments. The first argument is a probability or a percentile, right? The RAND function will go right in there. We'll simulate some percentile. And then 2 other arguments, the mean and the standard deviation, characterize the normal distribution completely. So let's put that into practice, right? So equals the norm.in function is what we'll do. The first argument is the RAND function, is this randomly generated number. The second argument is the mean. And then the third argument is the standard deviation. So what comes out is we've got a simulated return of 2.77%. That's based on the mean and standard deviation, and also this random number, right? So 0.69316, this corresponds to about the 69th percentile of a normal distribution. And what the function is doing is it's saying, okay, given the mean and the standard deviation, right? Give me the 69th percentile of the normal distribution with a mean of 0.69% per month and a standard deviation of 4.12%. And that corresponds, you know, if this was something with a mean of 0.69% per month here, and then a standard deviation of 4 point something percent, that would correspond to something right here, right? No, what about, let's figure out the point in the normal distribution where the area under the curve to the left, right, is 0.69. Give me the 69th percentile. And then what X value does that correspond to? In other words, what simulated return does that correspond to? So some background on simulating normally distributed data. Let's do one more simulation, and then in the next video, we'll build out this simulation spreadsheet, and I'll show you what we'll extend it to do stuff in finance, right? So let's simulate one monthly return in totally in one cell. We'll do this a lot. So equals norm.in. Suppose we want to simulate 1 month of simulated market returns based on historical data, right? So we use the norm.in function. The first argument of the function is the RAND function. And the second argument, we give some assumed mean and standard deviation, right? And then we've got a simulated return where it simulates a normal return distribution with a mean of 0.69% per month and a standard deviation of 4 point something percent per month. I got a simulated return of negative 1.546, right? So in future videos, we'll use simulated returns and see how to work with them in finance. Thanks for tuning in.